In this video, I'm going to cover examples from section 6.5, which is about the law of sines. Recall that the law of sines works in any triangle whatsoever if the sides A, B, and C face angles capital A, capital B, and capital C. Then the law of sines says that A over sine A equals B over sine B equals C over sine C. So we're going to make use of this law to solve various examples. Let's start out by solving the following triangle. As you can see, we're given two angles and the side between them. We're given angle B is 98 degrees, angle A is 45 degrees, and side C, which is between the two given angles, is 22 degrees. So to solve the triangle, we need to figure out the value of angle C and the value of the side length A and B. So we know the sum of the angles in a triangle sum up to 180. So this means angle C is 180 minus 98 degrees minus 45 degrees, which is 37 degrees. So now we know all the angles. It remains to figure out A and B. So using the law of sines, we see that A over the sine of A, which is 45, equals B over sine 98 degrees equals C, which is 22, divided by the sine of angle C, which we found out to be 37. So we solve for A and B. If we look at the ratios, A over sine of 45 equals 22 over sine of 37. We can cross multiply and solve for A to B. 22 sine 45 degrees divided by sine of 37 degrees. Make sure your calculator is set in degrees, and when you do this computation, the answer will be roughly 25.85. Similarly, if we use the proportion B over sine 98 equals 22 over sine 37, we cross multiply and solve for B. We see that B is going to be 22 sine of 98 degrees divided by sine of 37 degrees. You can do that with the calculator to get 36.20. The second example, we have to show that there's no triangle for which A is 4, B is 14, and angle A equals 60 degrees. So we have a situation like this. B is really long, so B is 14. Angle A is 60 degrees. And side A, which is the angle, the side facing angle A, something like this. A equals 4. A is too short to close up the triangle, so we're going to prove that no such triangle exists. So we can see that intuitively, but that's not a proof. So let's argue by contradiction. So what if such triangle existed? So if such a triangle existed, then the law of sines would apply. And that would mean that sine A divided by A would equal to sine B divided by b. Let's see what those are. A is 60 degrees, so we would have sine of 60 degrees divided by A, which is 4, equals sine B. We don't know what B is. Divided by B, which is 14. If we cross multiply and solve for sine B, we get that sine B is equal to 14 sine 60 degrees divided by 4. And if you do that with your calculator, you'll see that this gives 3.03, which is a contradiction because sine B cannot exceed 1. So our original assumption is wrong, namely that the triangle exists, so we can conclude that no such triangle exists. The second example has to do with finding two triangles for which A is 4.5, B is 5, and angle A is 58 degrees. So first, let's prove that there are indeed two triangles. Note that in such a triangle, the height would be B sine A, which is 5 sine 58 degrees, and that's 4.24. Now notice that 4.24, which is H, is less than 4.5, which is A, which is less than 5, that's B, and notice that angle A is 58 degrees, so it is acute. Combining those two conditions, we conclude that two such triangles exist. So let's figure out what they are and solve them. Let's start with the first triangle. I'm going to focus on the first triangle. Here we have side B equals 5. Here's angle C. A is 58 degrees. And we have side A equals 4.5. So B is slightly longer than A. So, to figure out or to solve this first triangle, we are going to start out by applying the law of sines. So we know 4.5 divided by sine A, which is sine 58 degrees, is equal to B, which is 5 over sine B, which is equal to C over sine C. If we cross multiply, we can solve for sine B is equal to 5 sine 58 degrees divided by 4.5. Using your calculator, we find that that's equal to 0.942276. And to find B, we take the inverse function. So B is sine inverse of 0.942276 0.276. Making sure the calculator is set in degrees, that gives us 70.44 degrees. We know two angles in the triangle, so we can figure out the third angle C by doing 180 degrees minus 70.44 degrees minus 58 degrees, and that's equal to 51.56 degrees. So we know angle C, we know all of the angles. The only thing remaining is to figure out what side length C equals to. And for that, we're going to invoke the law of sines again. So we have 5 over sine B, which we know is 70.44, equals C, side length C, divided by the sine of angle C, which is 51.56 degrees. So cross multiplying and solving for C, that's going to be 5 sine 51.56 divided by sine of 70.44, which is equal to 4.16. Now let's look at the second triangle that arises from this configuration. So let's recall what the first triangle is. So these dotted lines were parts of the first triangle. The second triangle is what I drew with the solid lines. So we have A, B. Now this is our new B and this is our new C. So remember, this length was 5, this was 4.5, and to create our new triangle, notice we have an isosceles triangle. Those two sides are equal, so this side would be 4.5, and angle A is still 58 degrees. Now recall that this angle here was the original, or the angle B in the first triangle, that was 70.44, and since this triangle is isosceles, so let's call this D, so triangle BCD is isosceles at C, so we know that this angle here, CBD, is also 70.44 degrees. So with that said, we can figure out angle B by doing 180 minus 70.44, and that is 109.56 degrees. Notice angles CBA and angles CBD are supplementary angles, so they add up to 180 degrees. So now in triangle ABC, we know angle A, we know angle B. Angle C would be 180 minus the sum of A and B, which is 58 minus 109.56, and that is 12.44 degrees. It remains to figure out side length C. We use the law of sines to do that. So we have 5 over sine 109.56 equals side length C divided by sine of 12.44. Cross multiply and solve for C. We get C is 5 sine 12.44 divided by sine 109.56, and that's equal to 1.14. Finally, let's look at an application. On a small lake, you swim from a point A to point B at a bearing of north 28 degrees east. So in a picture that would look something like this. So here's point A. We go from the north line and we make 28 degrees east, so 28 degrees to the right from the north line. So here's 28 degrees. So that's point B now. And then we go to point C at a bearing of north 58 degrees west. So at point B, we're going to go 58 from the north line. We're going to go 58 degrees west, which is 58 degrees to the left. So that is 58 degrees. And finally back to point A, and we know that point C lies 800 meters directly north of point A. So here's point C, and that completes our triangle, and we know B is 800. So the point from this problem is to find the total distance you swam. So I want to figure out all of the three lengths. This is side length A, we know side length B, and we need to figure out side length C. First thing we need to notice to solve this problem is that these north lines are parallel lines. So this gives rise to alternating angles. Here you have 58 degrees, so we know angle C must be 58 degrees because these are two alternating angles between parallel lines. So B is 58 degrees. Knowing angle A and angle B, we can figure out angle C. Oh, I apologize, this was not angle B, it was angle C. Angle C was 58 degrees, and we know that B is 180 degrees minus 58 degrees minus 28 degrees, which is 94 degrees. We know all the angles. We know side B. Let's invoke the law of sines. So we have A over sine of 28 degrees equals B, which is 800 over sine angle B, which is 94 degrees, equals side C divided by sine of 58 degrees. So we have two equations to solve by cross multiplying. Notice that A is equal to 800 sine 28 degrees divided by sine 94. I'm not going to find the answer just yet. And we have C is 800 sine 58 divided by sine 94. I'm not going to find the answer just yet to get a more accurate answer at the end. And of course, we know that B is 800. So A plus B plus C, you put all of the values in the calculator and we add them up. and that gives rise to 1856.59 meters.